Hello there, fifth graders. This is Mr. LaBeouf. In putting together a series of lessons for a particular grade, especially when you're beginning a school year, the most difficult decision for me is where to begin. Everything in math is connected. There are no inconsistencies, no contradictions. If you ever learn something in math that seems to contradict or doesn't go along with something you learned earlier, then you have to work through that and check with me perhaps, so that what you thought was a contradiction or something wrong really isn't. That's an important general point about the learning of math. Always make it consistent for yourself. You're telling a story to yourself in your mind. I help you along in that process, working through problems, homework problems, quiz problems, help you with that process. But you essentially have to do it yourself. Another thing that I'm fond of saying to my students is that my primary job is to tell you why things are what they are. And I take the position that the how is easy. Something we're going to do later on, dividing two fractions. Now, right now, that's a concept, a skill that is quite a bit beyond where you are now. But step by step, we're going to get there. And when we get to the division of two fractions, the rule is quite simple. Leave the first fraction the same, flip the second fraction, and multiply. Well, before you can divide two fractions, you have to know how to multiply them. So, in deciding where to begin, I cannot begin with the division of fractions. There are certain things that have to wait until we develop. But in this first video that I'm presenting to you for fifth grade, or it may not be the first, I may change my mind later, but early in fifth grade, we're going to talk about the standard multiplication algorithm for two whole numbers. Now that sounds like a mouthful. The word algorithm it kind of ends like the word rhythm from music with that strange THM, which kind of has a missing vowel in it. Algorithm. An algorithm in mathematics is nothing more than a series of steps to take to answer a question. That's all it is. It's a fancy word, but that's what it means. Algorithms appear at every level of mathematics. When you get to Algebra 1, there's an algorithm for solving something known as quadratic equations. Again, that has no meaning to you at this point, but if you stick with the program day by day, week by week, year by year, you tell yourself that story and you get to where you want to be. The four basic arithmetic properties with whole numbers, addition, subtraction, multiplication, and division, each have what I call, and many people call, the standard algorithm. They're not the only algorithms, there are others. The standard algorithms have become standard through the centuries because they're very efficient. They work, and they work very easily. But as I said before, my job is the why. So one of the purposes of this video is to take the standard algorithm for multiplying two whole numbers and explain why it works. We're going to have to explain why it works with a basic law of mathematics known as the distributive property. And I'm going to get us started by kind of breaking a rule that I have. I try as much as possible to explain why things are true. I actually could explain why all of these facts are true, but we have limited time, so I have to be a little choosy about the things that I explain. I'm definitely going to explain to you why we divide two fractions the way we do, for example. That'll be coming up. Weeks, months down the road. Just do your job every day. These are, of course, special numbers that are easy to multiply together. The algorithm, if you will, here, simply tells us multiply the 3 and the 2 in this case, and then the product of the two numbers will have the total number of zeros that appear. So 3 times 2 is 6. We have 1 0 there, 1 0 there. 3 times 20 is 60. 2 times 30 is also 60. All of these products, of course, begin with 6 because 2 times 3 is 6. And then you just count the total number of zeros in both numbers and tack them on. That's an algorithm. We could explain why it works based on what it means to multiply a number by 10 or multiply a number by 100, but we'll just accept these to be true. 2 times 300, of course, the 6 followed by 2 zeros. 3 times 200 results in the same thing. 20 times 30 is also 600 because you've got 2 zeros total. So a 6 followed by 2 zeros. You've got a couple that multiply to 6,000 here. 2 times 3 is 6, and we have 3 zeros. Same thing here, 2 times 3 is 6, and 3 zeros total. And I finished with 200 times 300, but we could go on forever, of course. The algorithms allow you to do that in general, that once you establish how they work, you can do them for any numbers. It might not be fun, it might take a lot of time, but theoretically, when you learn an algorithm, you can apply it to any numbers. That's why it's an algorithm. 2 times 3 is 6, and 1, 2, 3, 4. 1, 2, 3, 4. So 200 times 300 is 60,000. You are an entrepreneur, a business person, and you want to sell something for $300. Let's make this $300, just to give this a little bit of meaning. You're selling a ticket to an event that's very popular. A lot of people would like to come to this event that you're hosting. It's your business. Music, concert, something. And if you can convince 200 people to each buy a ticket for $300, you're going to gross $60,000. You'll bring in $60,000. Now, you probably won't be able to keep all of that because you're going to have to pay the band. And you're going to have to pay maybe to rent a place to have this event. But, you can take whole number multiplication and make it part of a word problem or a real life situation. So we will move on now to the next phase of this video. I'm now going to introduce you to a little piece of symbolism. I often say to my students, mathematicians can be lazy. You could use that word. Now, lazy has a negative connotation. It's a negative word. I don't want you to be lazy. Let's replace the word lazy with efficient. Yeah. It's kind of lazy, but efficient means you can get something done easily. Mathematicians decided centuries ago, it doesn't go back to ancient times. The ancient Greeks did not have this symbolism in their math, but probably going back about 500 years, around 1500-ish AD, mathematicians decided, hey, if we've got a number A and a number B, just put them right next to each other, and that means multiplication. So we don't have to write the x that we're familiar with from multiplication. So it saves the time and ink of writing the x. We agree that this means A times B, all right? A couple of examples. A equals 3, B equals 4. Now, if A equals 3 and B equals 4, AB is not 34. It's 12. Why? By agreement, because we agree that AB means A times B. Now, you can also have a number in front of a letter like that. This means 5 times A. Well, if we go back here to A being 3, if A is still 3, 5A, of course, is not 53, but 15. Very efficient. And another reason to sort of eventually do away with this x. We're not going to do away with the x immediately, but as you progress through middle school math, you're going to see the x for multiplication less and less, because eventually, some of you may be aware of this, we're going to use letters like x, y, and z to stand for unknown numbers in an equation. And to solve an equation, which is a big part of school math, beginning in the middle school years and going into high school and beyond, solving equations is a big deal, and those unknown numbers are frequently represented by the letter X, so we don't want to confuse with the multiplication sign. And by the way, this is not 6. You don't have to worry, that's still 32. So that's sort of an exception to the rule of when two numbers are right next to each other, it means multiplication. 32 is actually 30 plus 2 if you think about the place value of this 3. And let's see, kind of lost my train of thought. What if we wanted to write 3 times 2 without an X? Right? That's another thing. We cannot just put the two of them together like that because that would be confusing. So if we want to represent multiplication, when you've got two letters like A and B, or you've got 3 times A, just put them right next to each other. But if you want to represent 3 times 2, I'll write it the old way here, you have a number of options. The raised dot. Now we're going to be looking at decimal numbers this year. This is not a decimal point, it's not 3.2 because it's raised, it's up in the middle. So that means 3 times 2 or 6. You could put one or both of the numbers in parentheses. So this is 3 times 2, as is that, as is that. All of those say 3 times 2. I know what I was thinking of before. There's another exception to this general rule that when two numbers are right next to each other, it means multiplication. The first exception is just regular whole numbers that have more than one digit. Okay, those are still going to be what you think they are, what you've always learned they are. Another exception is something you're familiar with. This is the so-called mixed number. A big part of what we're going to do early in 5th grade is to understand what a mixed number is. But I'll tell you right now, it's not a multiplication, it's a sum. Again, for efficiency, mathematicians have agreed not to put a plus sign between the 2 and the half. 2 1/2 is 2 plus a half. We actually say the word and is addition. 2 and 1/2, 2 plus 1/2. So, but we just agree for efficiency to write it like this. And how do you know this is not 2 times a half? Just by experience, when you see this, you'll realize it's not 2 times a half. If you wanted it to be 2 times a half, you could do this with the raised dot or the parentheses like I said before. Now each of these are 2 times a half, and maybe you can appreciate at this point, you should be able to, that 2 times a half is actually 1. Familiarizing yourself with the symbolism of math is very important and yet very simple. There aren't that many symbols and rules for using the symbols that you have to use. And once again, the key is day by day, class by class, week by week, year by year, you do your best and you tell yourself the story. This is the famous and all-important distributive property. I'm not going to write that out. It's a word related to distribute. As a teacher, I frequently distribute papers to the class, quiz papers. You'll be experiencing that a lot. What do? I give a paper to each student, distribute. The distributive property is an important property, an interesting property, because it combines two operations. It combines addition and multiplication. And it can also involve subtraction here or here. We won't get into that today, but it works in a very similar way. So this A gets distributed to the B and the C, and then we add those products. Notice that the A is right next to the parentheses. There's that rule again. The A is being multiplied by the parentheses. The distributive property says when you multiply A times B plus C, you have to multiply A times B, which we just learned we can write AB, and then you add, you sort of bring down that plus sign, and distribute the A to the C as a multiplication, and you get AC. So this is the distributive law. A times, in parentheses, B plus C is AB plus AC, where this is A times B, this is A times C. And by the way, we have a rule that if we're going to evaluate this, let's say we have 2 times 3 plus 5. Well, let's first realize we can add 3 plus 5 to get 8. So what is the value of this entire thing? It's 16, right? It's 2 times 8. So let's just write that here. And now, using the distributive property, I can't write a 2 next to a 3, remember that? 2 times 3, raised dot, plus 2 times 5. Now here's a rule. It's part of what's known as the order of operations that we'll cover this year. It's just an agreement, that's all it is. The agreement we make is that when we're evaluating this thing here, we do both of the multiplications first. We don't do 2 times 3 is 6, plus 2 is 8, times 5 is 40. Now notice, this thing here clearly has to be 16. So if we just go left to right, multiply, then add the 2, then multiply by the 5, we don't get 16, so it's wrong. And because it's wrong, we agree that we do 2 times 3 first and get 6, and 2 times 5 next and get 10, and then the last thing we do is add. So this is another way of saying 2 times 8. We can say it as 2 times 3 plus 2 times 5. We're probably never going to do that. We're just going to know that 2 times 8 is 16. By the way, a prerequisite, that's a fancy word that means something you have to have accomplished before you could do something else. A prerequisite for 5th grade math and beyond is that you know the single-digit multiplication facts. And if you don't, you got to learn them really quickly. So 2 times, there's a few of them here. You got to know from 0 times 0, that's easy. 1 times 1, 1 times 2, 1 times, all the way up to 9 times 9. 2 single-digit numbers multiplied together. You need to know immediately that 9 times 9 is 81. 7 times 8 is 56. 7 times 9 is 63, and so on. Now, you can get that into your long-term memory so that you never forget, and you need to. Trust me, that's important. Now, multiplication is commutative. So this says A times the parentheses. The parentheses times A has to be the same thing. So we can distribute from the right here and write AB plus AC like that. Let's now take some whole numbers and use the distributive property to multiply them. I'm going to sort of reveal the magic right away, and I'm going to suggest to you that 3 times 67 is 180 plus 21. Let's break that down a little bit and see why. Well, it's very natural to think of 67 as 60 plus 7. There's a whole bunch of whole numbers that could add up to 67, but notice I'm going by the place values. We've got 6 tens, which is 60, and plus 7 ones. And we just saw that it's easy to do 3 times 60. 3 times 60, according to that algorithm, 3 times 6 is 18, 1 0, 180. So we distribute the 3 and get that, right? We get 180 plus 21, which is very easy to mentally do that. 3 times 67 is 201. Now here's how you learned it in 3rd grade. This is a simple example of the standard multiplication algorithm. 3 times 7 is 21. Put down the 1. Carry the 2. 3 times 6 is 18, plus 2 is 20, and there you go. Now here's what I like to say. What is really going on when you use this multiplication algorithm? It's what's above. It's really the distributive property that results in this very efficient algorithm of, putting down a digit and carrying 1. And notice in here, I didn't have to do anything other than single-digit multiplications. I did 3 times 7 and 3 times 6, but this is really a 60. But when you put the 1 down here, carry the 2, add the 2 to the 18, you kind of account for the fact that it's really 3 times 60. Another thing that we could have done here is, instead of putting down the 1 and carrying the 2, we could do 3 times 7 is 21. But for the second step, you have to now realize that that's 60, and 3 times 60 is 180. Put that down here. And this is essentially exactly how the distributive property worked above, except it's vertical. Now, we're going to move on to a 2-digit number times a 2-digit number. It's a little bit more complicated, but it's still the distributive property, and the standard multiplication algorithm still allows us to get it accomplished by just the single-digit facts. Just knowing that 4 times 7 is 28, and 8 times 6 is 48. You know those, and you can multiply any 2 whole numbers using the standard algorithm. So let's try 37 times 42. The first thing I'd like you to do is to get into the habit of estimating, or another, maybe a better way of thinking of estimation is number sense. We just learned an algorithm for multiplying numbers like 40 times 40. And why do I choose 40 times 40? Well, this number 37 is not close to 30, it's actually close to 40. And 42 is, of course, also close to 40. So let me introduce now another symbol, the squiggly equal sign. That's what I call it. Maybe it's got another name, but you don't have to learn it if it exists. Just call it a squiggly equal sign, or about equal to. That's what it means. 37 times 42 is about equal to 40 times 40. And 40 times 40, 4 times 4 is 16, plus the 2 zeros tacked on, 1600. So here's the thing about estimation. Estimation is important in not only in math class, but in life. A lot of times we don't need to know the exact answer to something. The estimation here can be very useful. Let's say we make a mistake in applying the multiplication algorithm. If we get an answer that's not kind of close to 1600, now you've got to be a little bit flexible there, kind of close. Sometimes you get really close with your estimate. Other times, it's just, you'll get a sense for when it's reasonable. If our answer is kind of close to 1600, then it's reasonable and we can be fairly certain that it's right. Now here's the standard multiplication algorithm for 37 times 42. And once we do that, we'll go through and ask why, and that's based on the distributive property. Here's the standard algorithm. Start with the first part of it is exactly the same as 7 times 42. And the algorithm there says 7 times 2 is 14. Carry the 1. 7 times 4 is 28. Plus 1 is 29. And I'm going to cross that out because that probably may not apply the next time. Now the next thing we do is we're going to multiply the 42 by 3, but this isn't really 3. It's really 30. How do we account for that? We put a 0 here. That pushes everything over and results in 30 times 42 rather than 3 times 42. So the standard multiplication algorithm is extremely efficient, and here's another word, it's elegant. Elegant. 3 times 2 is 6. There's nothing to carry. 3 times 4 is 12. Notice everything belongs in a column. Don't try to squeeze that 1 here with the 2. It has to go into a new column, the thousands place, is? Well, we know the answer is going to be near 1,600, so we know that the product of these two numbers is going to be more than 1,000. By the way, I just used the word product. When you multiply two numbers together, the result is called a product. The product of 37 and 42 is what we're finding. These are actually called partial products. This was 294 was 7 times 42. This 1260 is 30 times 42, and now we add them together. I usually leave out that plus sign when I'm doing it, but this is really what we do. Add the partial products to get the complete product. Now here's addition algorithm, right? Which I'm not going to get into. I assume you're good with that. 4 plus 0. 9 plus 6 is 15. Put down the 5, carry the 1. 1 plus 2 plus 2 is 5 and 1. Now, is that fairly close to 1,600? I'm going to say yes. Hopefully I didn't make any mistakes here. And like I said, sometimes your estimate results in something very close. Other times it's just kind of close. So let's look at the y. I've left the standard algorithm here where we got a product of 1,554. Now I've rewritten the 37 times 42 up here, and similar to an earlier, simpler problem, I've rewritten the 37 as 30 plus 7, and rewritten the 42 as 40 plus 2. Notice I put them each in parentheses, the parentheses right next to each other. Remember the right next to each other? That's a multiplication. This is 30 plus 7 times 40 plus 2. Now, here's a subtle point. This is one of the first examples of me introducing you to abstraction. All right, remember before we had A plus B times C, the distributive property. A plus B in parentheses times C, and we distributed the C as a multiplication to the A and the B, and then added those products. We have to see that entire parentheses as the C, and we can do that. C is a number. 40 plus 2 is a number. So watch what happens. This gets a little bit complicated for 5th graders. There's a lot here, but the structure of it is very simple. We're going to do 30 times 40 plus 2. And then this plus sign right here comes over there. And now we have 7 times 40 plus 2. And I want to repeat, all we have done is distribute this parentheses, this 40 plus 2 in parentheses, we've distributed it as a multiplication to the 30 right here, and then we add the 40 plus 2 distributed as a multiplication to the 7. It's exactly the same distributive property, with 40 plus 2 being the number that gets distributed, the C in my previous example. Do you see here that there are now 2 distributive properties? We do the distributive property again. Frequently, algorithms, and this is an algorithm too. This is called the standard algorithm of multiplication. This is more showing you the y based on the distributive property, but algorithms frequently have repetition of steps. So we use the distributive property again. 30 times 40 is a 12 followed by 2 zeros, 1,200. Now we bring down that plus sign, and 30 times 2 is 60. So we're done with this part. Now we have this plus sign, and we have to distribute the 7 as a multiplication to the 4 and the 2. The 40 and the 2. 7 times 40 is 280, and 7 times 2 is 14. Now, we need to add those to get the product of 37 and 42. But let's take a shortcut. Let's not just go left to right. Let's just recognize. Have we seen 1,200 plus 60 before? It's right there. Not a coincidence. The standard multiplication algorithm developed centuries ago. Probably took a while to develop it before it caught on. People agreed this will work. It's based when you get down to the foundation, it's based on the distributive property. It should not be a surprise that we see 1,200 plus 60, and that is this partial product from before, and then 280 plus 14 is the 294. I see that we're at 30 minutes. I try not to make these videos go too long. So I'm gonna close this one off and remind you that mathematics is a journey. Every step's important. Let's call it a journey up a ladder or a staircase. Climbing a staircase is fairly easy for you at this point, I would think. But some of you, sometimes we like to try to skip a step. Some of you might have long enough legs to skip one step, skip 2 steps maybe, and still climb the staircase. But it's harder, maybe even a little dangerous. I don't want to suggest that not learning math is dangerous, but there's kind of an analogy there. Don't skip steps. Don't skip vital steps in the understanding of the math that I'll try to provide you through the years. And then the journey becomes smooth. Most of the time. There'll be bumps, but you have to be willing to work through those little bumps in the road, and I'll do the best I can to help you. Now remember, how is easy. I'm kind of counting on you to learn the how through practice, through homework problems, and if you get something wrong in a quiz, the next time you get it right. So you teach yourself the how, I guide you with the why, and when you understand the why, the how will make sense, and trust me, you'll be able to learn the how better and get correct answers if you understand the why. So I'll break there. Enjoy the journey.